A complete understanding of black holes will always be impossible to achieve given that their interior properties are hidden by their colossal gravitational strength. A theory which tries to reveal their true nature is therefore impossible to verify through experimentation. The only way to understand black holes is to pay attention to their observable traits and mechanisms and form an intuitive solution which would also incorporate these same traits and mechanisms. In this video, I will analyze black holes using the theories in the RCP trilogy and see how they fare against actual observations of black holes and events surrounding them. Considering the contrasting forces of expansion and compression noted in Part 2 and 3, we can consider black holes not as singularities of light and matter, but merely as inflated particles with no egress for energy to escape from. In fact, it was noted in Part 3 that if particles could not evacuate excess energy, they would only grow as an ever-expanding sphere. Such sphere would not only be invisible as it does not interact with other things, but would also absorb light or other particles in every direction. These are precisely the properties of black holes. With every added bit of light, its radius will increase and in turn strengthen its gravitational effect. In Part 2, gravity was explained by the partial absorption of gravitational waves, but in this case, it would be a total absorption of those waves. However, if we truly analyze this interpretation of black holes, there are two unintuitive problems that arise. First, in the repulsive theory, it was postulated that gravitational waves can only deflect light and not reflect or change its speed in any way. Given this assumption, a photon which intersects the absolute center of a black hole will keep its geodesic path. If so, then black holes could leak extremely infrared photons because of the immense redshift effect in an almost negligible manner. This could nonetheless be a classical way to interpret the theorized Hawking's radiation, which would have the same effects but from different causes. Secondly, it was said that photons were the product of accumulated energy able to breach the global compressing forces. Under this interpretation, the only thing disabling such a property from black holes would be the immense funneling of energy required to breach the force which holds them together. Not only would this event be random at some point, but it would require a black hole that recently absorbed an enormous amount of energy in a meager interval of time. These conditions are analogous to tidal disruption events where a star is ripped apart and partially eaten by a black hole. Such events are relatively rare in our perspective, but we already observed many TDEs. However, none resulted in latter emissions of black holes. That is, until the AT 2018 HYZ tidal disruption event seemingly triggered a second and arbitrary emission of radio waves 3 years after the initial collision of its original star. How could a black hole fall dormant for some time and suddenly evacuate energy a second time? Could this energy come from beyond the event horizon, breaking our current theories of black holes? Perhaps the RCP interpretation of black holes is flawed in comparison to already accepted theories, yet dodging the concept of singularities, where mass and light would be concentrated into a zero-dimensional point, could be a better way to view these cosmic enigmas. In any case, black holes need to be analyzed carefully before accepting any interpretation of them as the whole truth, as this whole truth could never be proven by experimentation.